All right, David, are you ready to present?
Yep, I'm going to share my screen now. Thanks for the opportunity. It's very exciting to speak to sort of like-minded people. My background around the synthetic aperture radar and looking for snares is I'm involved in the reintroduction of lines into Zambezi Delta. 24 lines, there's now 130, but with a lot of snaring in between. And at the moment, we're busy introducing cheetah into the Zambezi Delta, and it's ticking over the founder population there. But again, we're running into snare problems. So that was my entry into into snares, and I came back October 2 years ago, saying, "Well, I really want to find out whether there's a way to deal with snares." Obviously, snares is one of the largest wildlife challenges in the world. We all know it kills about 30, the most common figures are um, quantitative figures, sort of about 13 million snares per year are put in Southeast Asian reserves. And in reserves around Africa that I deal with, it's quite common to have like 1,000 snares removed every year from different landscapes. And that's clearly not all the snares. And what we also know is snaring disproportionately threatens sort of apex predators, tigers, lions. It was really the result of the exploitation of wild dogs in the lower Zambezi. And even in our own program, it was a real snaring is the biggest challenge of reintroduction into unfenced areas for us. Uh, what we also know is, despite okay, looking for snaring by foot patrols and even sort of optimizing using information using Earth Ranger and that, um, we know we're not getting all the snares. And the few studies quantitative studies that actually have been done to test how many snares you actually pick up in the environment are quite a dismal tale. So even when trained rangers know there's snares there, they typically only pick up 20 snares, and there's diminishing returns. It's harder to pick up the snares that you miss, so you can't spend twice the time and double the snares. The snares that you miss are harder to get, and so this is a real challenge. And I came back, and in fact, I went to WILDLABS.NET. There was a chat about how to deal conservation to deal with snaring in 2017, and um, so I briefly had a look in what people had been doing. There was one small study using ground penetrating radar. This was the setup. Obviously, it's not operating at scale. I then connected up with the Radar Research Institute in University of Cape Town, and Prof. Ings had developed a synthetic aperture radar that could fit on a light aircraft, a helicopter, or a drone. And the advantage of using synthetic aperture radar is it's got a wide search area. So you can send up a drone 120 meters, and you can fly. Eventually, you'll be able to fly at 135 kilometers an hour. And the synthetic aperture radar works at 2 gigahertz, which means that it can penetrate canopies. It obviously can't penetrate the trunks of trees, but canopies, it can operate in night, in poor light, and in mist. And suddenly you're independent of road infrastructure, and you can cover large areas. And detection of snares using radar gives the option to locate the snares here up with 5 meters, but because we can actually detect it within 2 meters, because actually knowing the position of our drone and knowing the position of the reflection is quite there. So here's just a quick look at our test synthetic aperture radar. It's got a transmitter in 5 milliwatts, sorry. Uh, and it's at 2,500 megahertz. And this allows us to actually penetrate vegetation. frequency modulated, and fully polarimetric. That means we get 4 channels of information which help us identify the target that is bouncing back to us. And it weighs 3 kilograms. At the same time, we were looking and we testing a long endurance drone, and we working together with FlyH2 with a hydrogen fuel cell drone. The advantage of using hydrogen is that it's more power dense than lithium-ion batteries. You can generate it on site. You can generate green hydrogen on site using solar power and water to generate the hydrogen. And yeah, so that's how we envision it. And this really gives us the opportunity to scan large areas. Here's the Serengeti National Park, and it actually allows us to actually search and locate snares over large areas. Here's the drone flying at 122, and that's the scanning area, and that's how the radar works. So far, we've done 3 trials at 3 different sites. Our first trial looked like that. That CR1, CR2, CR3 are targets which we could actually, that's the radar scan of 1 kilometer wide, and we can actually pick up the targets. We can't identify the targets. Our second trial, we got a lot better at that, and we've got consistent returns, radar returns from our trials in all 4 polarizations. So we get into the stage is that we're generating the data that we can actually look and identify the targets. This is still early days, and this is large of our problem. I mean, people are really keen to have us to try this out in the reserves, but we're really struggling to get money for the technical innovation. People are much more willing to fund off-the-shelf products, and we're finding it's a lot more difficult to get the funding to actually develop the product from the ground up. And lately, we've added to our team the University of Ulm, and the reason why we've added Ulm, Christian Waldschmidt's the head of the Institute of Microwave Technology, and they use a similar synthetic aperture radar, and they can detect 0.5 millimeter diameter tripwires between landmines. Okay, so we've got our drone, and we can detect larger targets, and we now need to invest in identifying the targets, discriminating snares from other targets, and we've teamed up with the University of Ulm, and we collaborating, and we've got a master's student starting at the end of this year. And they already have the algorithms to detect finer wires than that are typically used in wildlife snaring. So we're quite excited about that. And then just to cover, I mean, really our hope of this technology is once you can fly large areas and detect snares over large areas to within 2 meters and predictably identify them, obviously you can save millions of animals' lives. You can remove the greatest threat to carnivore populations in protected areas and avoid costly punitive responses to poaching. And I really believe as a single conservation intervention, developing a way to locate snares at scale has been one of the biggest conservation paybacks. Okay, thank you.
Wonderful. Thank you so much. Definitely jump in the chat. If sounds like looks like there are a few questions in there for you. So it'd be great if you could jump into the chat to answer those, David. And I also just flagged some relevant work by my team at WWF working on, Eric Becker and others are working on similar related stuff. So that might be interesting to check out.